Hi guys, my name is Monica and I'm gonna quickly show you my Max MSP patch that I developed for audio processing and effects module at Glasgow Caledonian University. So here I am in presentation mode and let me just quickly show you how it works. So here it just starts looping from the beginning. So our task was to produce sound accompaniment for a set of photographs that represent the UK's changing landscapes. The photographs will be projected onto a gallery walls as part of an art installation aiming to bring awareness around the issue of industrial pollution. So there we go, that's the view of the patch. And here I have all of these pictures that I used. They are shown in fpic object. And for each of the picture, there is one subpatch, like just here. So let me maybe start from showing you each of the subpatches. The first one is additive synthesis. And it's fairly simple patch. I used here arpeggiator that was taken from an example from this book, Electronic Music and Sound Design by Alessandro Cipriani and Maurizio Giri. So here we have a load bank object that it's sending bank as soon as the patch is loaded, so as soon as you open it. And it's sent just to metro object, which is a metronome. It's set to 250 milliseconds, so it means that it's sending 4 banks per second. So we're starting from 0 Hertz, and with every bank to this first number we are adding 1. So here it's working as a simple recursion loop. So let me just reset it. So it's starting from 0, and with every bank you're incrementing this number by 1. At this point we would go from 0 Hertz to infinity, and at some point we would move outside of the human hearing range, which wouldn't make much sense. So I used here this modulo object, and thanks to this we'll have set of frequencies from 0 to 12. So this is creating 13 notes. And this is working on basis n-1, so we will have sounds from 0 to 12. And this would be also outside of the human hearing range, so I added this offset. I added 60, so we are starting from 60 and we're going to 72 Hertz, and we're going back, and it's just looping. So there we go, that's how it works, this arpeggiator. And these notes are sent to these envelopes, which I chose actually on random, just them to look funky. And these envelopes are applied onto various wave generators. Here I have sinusoidal one, here triangular, rectangular, sawtooth, and again sinusoidal. So this first one is a fundamental frequency, and second, third, and so on, these are integer multiples of the basic tone, and these are called harmonics. So here I have 4 harmonics altogether, but you can create how many you want. So this could be like 100 even. Doesn't make much sense, but you could of course do this. And in the end I just did a simple delay loop just to make it more interesting. So this signal goes here, the gain slider, and I added these 2 messages which are going into line object, and this is causing this gain slider to go from value 0 to 127 units over half a second. This is 500 milliseconds, so half a second. So this is causing them to go backwards from 127 to 0. So from 0 to 127 and back. So let me turn on the audio so you can actually hear it. Yeah, that's very simple, so let's move on to something more interesting. And this wind subpatch was created based on a book by Andy Farnell, Designing Sound, which is very interesting and very inspiring, and I would suggest you all to get this book. Although he is creating patches in PD, pure data, so this is not exactly a Max environment. The objects are very similar, but it's not exactly the same. So you have to learn how to translate these PD patches into Max, which is not always so obvious. But this one is quite easy. It's just a white noise generator here with different filters applied onto it. And these 2 cycle objects, these are creating wind gusts, so it makes effect of wind just blowing at different speeds. And this goes here, and again we have these buttons. This is quite realistic effect, I have to say. I really like this patch. Next one is AM synthesis, which means amplitude modulation. This is very simple. So we have again arpeggiators that work on the same basis as this one that I showed you previously. I just changed these values here, incrementation, modulo, offset. I chose these values because I just like how it sounded, so you can choose whatever you want actually. And this first arpeggiator is creating carrier frequency, and the second one modulator frequency, which is modulating the carrier. So this works on similar basis as ring modulation, only the modulator frequency is changed to unipolar. So we moved it up by 1, so it's above the x-axis, and we multiplied it by half, so the sound won't clip. And these 2 are just multiplied together. So there we go. This sounds more or less like a motor, like you're driving a car and you're speeding up and changing the gears. Well, not exactly, but let's assume so. Next patch is electricity one, and it was also created based on Andy Farnell's book. I just made it much more simpler than there in the book, so there are only 2 subpatches. One is making humming noise and the other one is sending sparks. Let's look into humming one. This is very simple. There are two phasers which are working on very similar frequency, and this is generating a slow beating at 0.4 Hz as it's written here. And that was clipped here to add more harmonics, and there is also noise source, white noise source, which was low pass filtered and multiplied because it's just very low signal, so it was multiplied by 1500, and these signals were multiplied again by each other and again amplified. Spark subpatch. This loop here is creating random banks. So it will mean that these sparks are sent in random intervals between 0 and 3 seconds. So they can be sent just one after another, or at maximum after 3 seconds. And these banks are going to these envelopes. This envelope is applied onto a white noise source. And this envelope causes this sinusoidal generator to sweep from 7 kilohertz to 20 hertz. And these were again added to each other and clipped because I just liked how it sounded, more harsh when you clip it, and amplified again. That's it. And these are going together to gain slider. And this is quite loud noise effect, louder than the others, so I had to make the maximum value 80, so it will sound more equal to other subpatches. Next subpatch is glitch, which is making sort of computer noises, beeps, and so on. And to explain it, maybe I will get rid of this for a second. I will connect it here. So this phaser object is used here as a reference oscillator. Let me open this help menu for phaser. So that's how it looks like, this sort of wave. And these objects are used to determine which part of the wave we'll take under consideration. So this one means that we'll look at the value above half of the amplitude, so this is the stop part. And in this time, we'll have this sinusoidal wave generator generate wave at 440 Hz. Whereas here, in under half, so in this part, we will have it generating 220 Hz. So that's basically how it works. And these objects rate, they will create more or less teeth per second. So for example, here it will make 4.2 more teeth per second than it's in the basic wave. So here we go, let me go back to this. Yeah, so there's there are a couple of different wave generators, and they're just driving each other, You can add different objects here, make it much more complicated. So at this point, this patch is making kind of random noises, but if you would choose here these values in rate objects, if you choose them to be integer multiplies of each other, so for example, that would be 0.1, 0.2, 0.4, or whatever, this will cause this patch to make more melodic sounds, more musical, let's say. And at this point, it sounds like this. So it's very cool, it's very useful in sound design, you can make different effects with that. And this R2D2 effect was also taken from Andy Farnell's book. It is working basically as an FM modulator. It is frequency modulator. So here I created these sub-patches that are creating random numbers, and they are used to drive inputs of FM synthesis. And the difference between AM and FM synthesis is that here it's the frequency of the carrier that is being changed over time by the modulator instead of the amplitude. Yeah, that was later low pass filtered and high pass filtered as well. So yeah, that's the effect of it. Yeah, so thanks to this random number generator, we have this effect of total randomness, sometimes you're not getting any input, so there are bits of silence, which is pretty cool. You can use it in sound design as well. It's very useful. If you want to, for example, substitute audio for Star Wars, you can use it as R2D2 voice. And that's it. So that was the last sub-patch. And now let me explain you what's going on here. So here you can set time in seconds, and this goes as a write input to metro object, metronome again. It's set by default to 5000, so it will cycle at 5 seconds. This will cause these pictures to change at rate of 5 seconds or 7, as I said here. And Metro is sending bangs every 7 seconds to the counter, which is changing these bangs into numbers, 0, 1, 2, so on. And these numbers are sent to select. And selector is choosing output based on these numbers. So first it will start with 0, 1, 2, 3, 4, 5. And I used here trigger object. Actually, I don't think you would have to, but I just use it to make it more clear, and just to be sure that everything works in correct order. So this is basically used for ordering bank messages or other messages as well. And it works from right to left. So when we receive here signal, so we are at 0 and we are receiving signal, and then the first bang goes to the picture, so it's triggering this picture to open. Next bang goes to the previous sub-patch, so the one that was before, so here, to turn it off. And last bang goes to the new patch to turn it on, so this one that will correspond to the picture here. So these two are connected. So here we have additive synthesis on, which is just here. So first input is for turning on the sub-patch, and right input is for turning it off. So here it will work similarly, and first bang goes to the next picture to trigger it. Next bang goes to previous sub-patch to turn it off, so to this one. So additive is off now. And we're triggering new one to turn it on. So this is wind subpatch, which is here. And it will go like, it will loop forever, you know. It works similarly here, so when each output is triggered, then we're going through this cycle. Yeah, so this is on-off button, and I send it via this object to here to turn on and off the EasyDuck object, so we can actually hear something. And I used here remote messaging. This is S, this is short for send, and this is R for receive. So that's just used to make the patch look more tidy. Here, of course, I used it as well, so this is send for additive, this is receive for additive on. This is send for wind on, this is receive for wind on, and so on and so on and so on. And that's it, that's everything. I hope you like that. So you can leave the comment with some suggestions, and thanks for watching.